Hi guys, it's Mr. Krieger. We're going to be doing lesson 3 today. And basically we're just doing the first 2 pages of this lesson. And the other part of the lesson we will do live in class. So what we're going to look at first is solving absolute value equations, and we're going to do a little review of absolute value. All right, so it says, what does it mean when you're asked to figure out the absolute value of a number? What that's essentially saying is that the distance the number is from 0, the number's distance from 0. What's interesting about that is distance is always a positive number. When we talk about how far away something is from something else, it's never going to be a negative number. It's always going to be a positive number. So in essence, when you see something like an absolute value of -10, we're asking, well, how far is -10 away from 0? And since the distance is a positive number, from -10 to 0, that's 10 units. So you get the value of 10. And you can also think about it, the easy way to think about it is whenever I see an absolute value sign, what I'm going to do is I'm just going to take the positive of the number. If it's already positive, like this one, I'm going to leave it positive, 5. But if it was negative, then it's going to become the positive of that number 10. And again, the reason mainly is because the distance from -10 to 0 on the number line, distance always having to be positive, is 10 units, okay? Now, if we do some operations with absolute values, the absolute value sign can be treated like parentheses in the sense that you have to deal with all the things in the absolute value signs first. So here we're going to take account of what the value of this thing is before we actually do any operations with it. The value of the absolute value of 5 is 5. We have a plus here. What's the absolute value of -3? It's +3. And now we can do the operations. Now we have no more absolute value signs. 5 plus 3 is just simply 8. All right, let's take a look over here. Well, here we have the absolute, I'm going to draw them larger, the absolute value signs here, and we have stuff in them, and we've got to resolve what's inside here first. This is just -4. It's not, those are parentheses, not an absolute value sign. So it's -4 plus 6, which is 2, and the absolute value of 2 is 2. Okay, here we have the absolute value of -2 plus just -5, that's parentheses. So let's get rid of the parentheses and the absolute value sign, but we got to resolve this first. The absolute value of -2 is 2, and this is still -5, and we add these together. 2 plus -5 is -3. All right, the next one is similar, except this is the division sign. We're doing the absolute value of -14 divided by -2. So we've got this becomes 14 divided by -2 is -7, okay? So absolute values, again, it's always going to be the positive of the number. It doesn't mean your answers are always going to be positive, because after you do operations, especially when the operations are no longer in absolute value signs, you could conceivably get negative values, but not from values that are strictly in the absolute value sign. All right, now let's take a look at another skill. Here are equations that involve absolute values. So here we've got the absolute value of x equals 5. So we got to solve this. So obviously x is 5, right? But are there any other values that will make this statement true? Well, we know that if x equals 5, then the absolute value of 5 equals 5. But what about the absolute value of -5? Isn't that also 5? So you actually get 2 answers for this problem. X equals 5 is a solution to this problem, but so is x equals -5. Because when you put -5 into the absolute value sign, it becomes +5, therefore satisfying this equation, and therefore you have 2 solutions. It's kind of like, later on in the year, we'll learn about quadratic equations, which you probably have a little familiarity with. And with quadratic equations, you also get 2 possible answers, and that's what we're going to get here. So let's again think about possible solutions for this one. So the absolute value of 2x is equal to 6. I'm sure you could think of one answer, x equals 3, because 2 times 3 is 6, and the absolute value of 6 is 6. But also, -3 will also give you a correct solution for this problem. So you get 2 answers here. Let's try the next one. Can you think of a value for x that will make this true? What plus 2 equals 12? Okay, everybody knows x would be 10. 10 plus 2 equals 12. But is there another value that will make this a true statement? Let's think about this. If you can use a negative value here, what negative value for x would make this true? How about if x was -14? Let's see, if x is -14, what we're going to get is -14 plus 2 in the absolute value sign. Let's think that through. -14 plus 2 is -12. So this inside the absolute value signs here is going to become -12, but the absolute value of that is 12, which means you have 2 solutions as well. How about this last one we have? And let me write a little larger so you can see it a little better. It's absolute value of x plus 1 equals -5. Think of what value for x will make this true. Let's give it a minute, think about it. What value of x do you think is going to make this true? You're not going to find an answer to that, because no matter what value you put in for x here, once you add it to 1 and take the absolute value of it, it's going to make it a positive answer, which means this could never be negative, because everything on this side is in the absolute value sign. This side cannot be negative, so therefore there are no solutions here. Well, there's none, okay? Now you might have said, but we had negative answers here. Now, and here. The reason is everything on this side is in the absolute value sign. Every single thing is in the absolute value sign. When this thing gets resolved, it's going to become positive, and a positive number cannot equal a negative number. If you take a look what we had here, we had this thing was in absolute value signs, but this was not. Absolute value of -2 is 2, but this was just -5. Now you don't have any more absolute value signs, so this could add up to a negative number. But when we come back to this problem over here, everything on this side of the equation is absolute value signs. It's impossible, once you get rid of these absolute value signs, to have a positive number. Now, what do we do? Do we have a technique that we could use to solve these types of problems? It seems like we get 2 answers most of the time. There's 2 answers for here, 2 answers here, 2 answers here. Here there was absolutely no solution, so there was nothing there. But is there a strategy that we could use? Yes, this is what we're going to do. When you have, and in fact, I'm going to actually do this on a separate sheet of paper so I can write it a little bit larger for you. I'm going to rewrite this problem. What we have for number 7 is absolute value of x plus 2 equals 12. Here's what you're going to do. Since we know we could possibly get 2 solutions, we're going to write 2 equations without absolute value signs. One equation is just going to be the equation exactly as it is, but just without the absolute value signs, as if we just ignored them. That's going to lead to one of the correct solutions. Let's actually do that now. -2 minus 2, and we get x equals 10. Oh, look, that was the question that we did a little earlier, right? We did it mentally, but now we're actually looking for a technique. Now what do? There's a couple of ways you can go about this, but I'm going to do it the following way. Everything on one side of the equation is going to have to be made opposite sign. Positives become negatives, negatives become positives. Everything on the other side is just going to remain as it was. Now you could choose which side you want to change. Now obviously most people are going to opt to change this side since there's only one thing on this side, and that's fine. But I'm going to, for reasons that I'm not going to go into now, I'm always going to change this side. So now that I'm going to rewrite this equation out without the absolute value signs, I'm going to change everything on the left-hand side to opposites. Well, the opposite of x is negative x, and the opposite of 2 is negative 2. That was all left side stuff. On the right side, I'm not going to change that at all. Now I'm going to solve this equation. Plus 2, we get negative x equals 14. This is like negative 1x. We got to divide both sides by negative 1, and we get x equals negative 14. And look, those are the solutions we got when we just did it mentally. So here we have a technique that works. Now, some of you might say, what would have happened if I just made this side the opposite? It will work. As I'll do it now so you can see. If we take this equation, leave this side alone, but change this side to the opposite number, and then subtract 2 from both sides, you're also going to get the same answer. But if you go on to more advanced mathematics, there's a technical reason why you want to change the side that's in the absolute value signs. But again, for our purposes, if you want to just change this side, that's fine. I'm not going to be doing that in my lesson with you. I'm always going to change the side with the absolute value on it, okay? Let's go take a look at the next problem. I'm going to write it a little bit larger. So here we've got, this is problem number 8, absolute value of x minus 6 plus 12 equals 17. Now, we want to isolate this piece here, needs to be it's like a variable. We want it on one side of the equation with nothing else. So let's subtract 12 from both sides. We still have the absolute value of x minus 6, and now it equals 5. And now we're going to use the technique that we just talked about, which is to make 2 equations out of it. One equation is just rewrite the whole problem, no absolute value sign, and solve. Plus 6, x equals 11. We've got one solution already. What about the other side? Remember the way you might do it, get rid of the absolute value signs and make this negative 5. I'm going to do it by doing everything in here the opposite. Negative x, the opposite of x is negative x, the opposite of negative 6 is positive 6. This side I'm not going to change. Remember, you only change one side. Subtract 6 from both sides, you get negative x equals negative 1. We got to get x by itself, so we're going to divide by negative 1, and we get x is positive 1, and we get 2 solutions, which we should always just check to see if they work. So let's go back and see if this works. So plugging 1 back into here, 1 minus 6 is negative 5, but the absolute value of negative 5 is 5, and 5 plus 12 is 17, so that works. And 11. 11 minus 6 is 5. Absolute value of 5 is 5, and 5 plus 12 is 17, so that works just fine. All right, let's go take a look at some more problems here. All right, so in this particular problem right here, and again, let me grab another sheet of paper so I can write this a little bit larger. I'll put this in here so this is, okay. So we got absolute value of x minus 5 equals 3. We're going to treat the absolute value as a thing we want to isolate. First thing we do when we solve equations, we want to add or subtract. We want to use the additive inverse property here. Add 5 to both sides. This side is going to be 8. This cancels out, and this becomes 2 times the absolute value of x. Again, we want to get the absolute value of x alone. Now we're going to do the multiplicative inverse. We're going to divide by 2. So we get the absolute value of x equals 4. And we're going to make 2 equations out of this. One equation is going to be x equals 4. The other equation is negative x equals 4, or x equals negative 4. Those are the 2 solutions there. All right. Let me look ahead and see if there are any other problems. Yeah, I'm going to do 1 or 2 more of these types of problems. Let's look at number 11. I think I have enough room here to work. Okay, so for number 11, again, what we want to do is we want to isolate the absolute value piece. So we're going to want to divide both sides by 3. Therefore, we get the absolute value of x plus 7 equals negative 5. Now we can make our 2 equations. One equation is x plus 7 equals negative 5. And the other equation is negative x minus 7 equals negative 5. Solving this, we get x equals negative 12. Here we'll add 7 to both sides. We get negative x equals 2. Divide by negative 1, and we get x equals negative 2. So we have solutions x equals negative 12 and x equals negative 2. Let's see if these work. If we plug negative 12 in here, negative 12 plus 7 is negative 5. Absolute value of that is 5. 5 times 3 is positive 15. Not possible. This is no good. Let's try the negative 2. Negative 2 plus 7 is 5. The absolute value of 5 is 5. 5 times 3 is 15. 15 does not equal negative 15. There are no real solutions. Just like we saw on the previous page, there are problems where you can't have a solution because the side that has the absolute value on it can never be negative. And that's what we had here. Once we divided by 3, what's in absolute values can never be negative. I mean, inside there can be, but once you take the absolute value of this side, it's going to become positive. So that could never be equal to negative 5. So in this problem here, there are no solutions. Okay? Number 12 is straightforward. You can try that one on your own. Let's take a look at number 13. Number 13 is an issue. It's a simple problem. You know, we're going to subtract 13 from both sides. We get 2, absolute value of x equals 4. Divide both sides by 2. The absolute value of x is equal to 2. And remember, you're going to get 2 answers here. X equals 2, and I'll just do this quickly. X equals negative 2. You want to check this. This one should work fine. This side is positive. There should be no issue. So absolute value of 2 is 2. 2 times 2 is 4, and 4 plus 13 is 17. That works fine. If we put negative 2 in there, the absolute value of that's going to be positive 2. 2 times 2 is 4. 4 plus 13 is 17. Both of these solutions are perfectly fine. You get 2 solutions here. All right, last problem. Here we have a problem with a fraction in it, but it's really the same kind of thing that we've been doing. You're going to want to make, it's already, the absolute value part is already isolated, so you just want to make 2 equations out of it. One being 1/2 x plus 8 equals 14. If we solve that, we get 1/2 x equals 6. And then remember, the thing to do when you have a coefficient that's a fraction is to use the multiplied by the reciprocal. This side will just become x, and that side will become 12. So that's one possible answer. On the other side, what we're going to do is negative 1/2 x minus 8 equals 14. Remember, again, notice I changed everything on this side to the opposites. 1/2 x became negative 1/2 x. 8 became negative 8, but the 14 I didn't touch. Add 8 to both sides. We're going to get negative 1/2 x equals 22. Multiply both sides by the reciprocal, positive 2. Actually, the reciprocal will be negative 2. So we're going to multiply these sides by negative 2 over 1. And this side by negative 2 over 1. We're going to get x equals negative 44. Let's check. Those should work. Because this side is positive, but let's just double check. If we plug 12 in here, half of 12 is 6. 6 plus 8 is 14, and the absolute value of 14 is 14. Let's try the negative 44. Negative 44 times a half is negative 22. Negative 22 plus 8 is negative 14. But once we do the absolute value, we're going to get positive 14. So here we got the 2 solutions. And let me just make a quick summary for you of how you solve absolute value equations, okay? So here we go. To solve absolute value equations, the first thing you want to do is isolate, by getting it by itself, isolate the absolute value sign, everything in the absolute value sign. Once you've done that, you're going to make 2 equations. Make 2 equations. And that's going to be the first equation. First equation is just drop absolute value signs and solve. The second equation, we're going to negate, or do the opposite. Do the opposite signs of all terms on only one side of the equation. Okay, then solve. The last thing to do is to check, and you're not just checking yourself, You're not just checking to see that you got it right. What you're also checking for is to see if there's a case, which we've seen on a couple of occasions here. We're checking a case where there's actually no solution. Now let me find a case like that. Yeah, remember this case right here? When we try to solve it, we got two answers, but when we plugged them back in, they didn't work. So the reason for the check is to make sure that the two solutions actually work. Okay, the rest of the lesson we will do in live together.